Hi everybody, this is Dr.T.ANTONY Santosh, Assistant Professor of Chemistry, St.Joseph's College of Arts and Science, Cuddalore. Now I would like to explain some of the topics in Introduction to Molecular Structure, which is the main physical chemistry paper in the second BSc Chemistry students. Let us move on to the video. First, I would like to explain you what is photoelectric effect. We may be knowing what is photoelectric effect. Let us see the picture which is shown to you here in this diagram. In this slide, we could see what is photoelectric effect. So we may know the metal consists of different particles of atoms and every material possessing electron. This photoelectric effect is the effect of electrons by the attack of photo. Photo means light. The light is not merely light, it is the light radiation. So it is the phenomenon in which the electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. The effect is often defined as the ejection of electrons from a metal plate when light falls on it. So the metallic plate is exposed to light radiation or electromagnetic radiation. When the electromagnetic strikes the metal, there will be ejection of electrons. This happens only when the sufficient amount of energy, which is called threshold energy, is striking the metal surface. So what is threshold energy? The necessary or sufficient energy to eject an electron from the metal surface. Okay. So here the phenomenon is studied in condensed matter physics and solid state and quantum chemistry also to draw inferences about the properties of atoms, molecules and solids. So we know E is equal to h nu and nu is equal to c by lambda. What is h nu? H is Planck's constant, nu is frequency of radiation. So the frequency of radiation nu may be further explained into c by lambda. C is the velocity of light or light radiation and lambda is the wavelength. So the Planck's constant multiplied by frequency of radiation, and the frequency of radiation is velocity of light divided by the wavelength, which gives us the product value of energy. So we know the energy is quantized. The energy is in whole, not in fractional values. Okay. Let us see some other important points of photoelectric effect. When the radiation such as gamma rays, X-rays, ultraviolet radiation and even visible light fall on metals, electrons are emitted, or I could say ejected. This phenomenon of emission of electrons is known as photoelectric effect. The properties of photoelectric effect, we should know about that also. Okay, so when the radiation is gamma rays, X-rays, UV and visible or such kind of radiation, electromagnetic rays, so these are having the ability to eject the electrons present in the metal surface. You should know about the properties of photoelectric effect. The photoelectric effect has three important characteristics that cannot be explained by classical physics. So classical physics has its own limitations that we know already, and we should know what are all the points, what are all the properties of photoelectric effect now. The first point is the absence of a lag time. Second point is the independence of the kinetic energy of photoelectrons. on the intensity of incident radiation. And third point is the presence of a cutoff frequency. So these are the important properties of photoelectric effect which cannot be explained by classical physics. Okay. So let us move into the new topic, next topic, that is Heisenberg's uncertainty principle. So uncertainty means the instability or not a fixed position. Like that we will get the meaning. And that meaning or the principle is explained by the German physicist Werner Heisenberg. So the Werner Heisenberg, he explained the position and the velocity of an object. Okay. So uncertainty principle, also called Heisenberg's uncertainty principle or indeterminacy principle statement, articulated in the year 1927 by the German physicist, that the position and the velocity of an object cannot both be measured exactly at the same time, even in theory. So this is what the Heisenberg's uncertainty principle. But let us see some of the graph and equation form of Heisenberg's uncertainty principle. So in this graph we have momentum distribution as delta p and position distribution as delta x, and delta p into delta x is greater than or equal to h cross. So this is what we have, that is uncertainty regarding to momentum is delta p, and uncertainty regarding to position is delta x. Heisenberg's uncertainty principle states that it is impossible to measure or calculate exactly both the position and the momentum of an object simultaneously. This principle is based on the wave-particle duality of matter. It is mainly the wave-particle duality of matter. Okay. Let us see the next topic of our presentation. So this is a new topic regarding the black body radiation. So it is also related to the radiation topic, so which is present in quantum chemical oriented syllabuses. Okay, so here what is black body radiation? It is an object. What is black body? An object that absorbs all radiation falling on it at all wavelengths is called a black body. So whatever may be the radiation falling on it, whatever may be the wavelength, it will absorb. So that kind of material is called black body. So you may be knowing about black hole. So some are knowing that it is not possible, some are saying that it is not possible, it is a theoretical hole, like that, but it may be present. So like black hole, it is black body. When a black body is at a uniform temperature, its emission has a characteristic frequency distribution that depends on the temperature. Its emission is called black body radiation. Okay, so let us look at the second point of the slide. Black body radiation, energy radiated by any object or system that absorbs all incident radiation. Energy radiated by any object or system that absorbs all incident radiation. Okay, the term usually refers to the spectrum of light emitted by any heated object. Clear? Okay. So the term usually refers to the spectrum of light emitted by any heated object. So all heated objects are emitting radiation, and all the radiation will be absorbed by the black body material, which is called black body, the material. Common examples include the heating element of a toaster and the filament of a light bulb. So the toaster is hot in nature, the light is hot in nature. So these two things are uh, taken into our consideration of examples of anything which emits radiation. Let us see our next slide as a question one. Why is it called black body radiation? A black body or black body radiation is an idealized physical body that absorbs all incident electromagnetic radiation, regardless of frequency or angle of incidence. So, whatever may be the angle, whatever may be the frequency, a black body is an idealized physical body that absorbs all incident electromagnetic radiation. The name black body is given because it absorbs all colors of light. It absorbs all colors of light. A black body also emits black body radiation. So a black body, which is a material which is which has the ability or capacity to absorb all the radiation, or having the ability to emit a black body radiation. Okay. So let us see some more points in the slide of black body radiation. The black body radiation is also called thermal radiation, cavity radiation, complete radiation, or temperature radiation. So this black body, also the material which has the ability to absorb all the radiation, is called black body, and it has its own emitting property. That emitting property is called black body radiation, and that is also called thermal radiation, cavity radiation, complete radiation, or temperature radiation. And there is one more very important thing, that is, astronomers consider stars to be approximate black bodies. Stars to be approximate black body. That is, they are capable of absorbing light at every wavelength without any reflection. So without any reflection, they are having the ability to absorbing light. For example, the hottest among stars with surface temperatures of 10,000 Kelvin or more will emit most of their radiation at ultraviolet wavelength. So it is an amazing fact that the hottest of all the stars, that is 10,000 Kelvin or more, will emit most of their radiation at ultraviolet wavelength. Okay, let us see the next topic of electron diffraction. Electron diffraction. It is a technique that allows determination of the crystal structure of materials. So it is just a technique, not only just a technique, it is an important technique. When the electron beam is projected onto a specimen, its crystal lattice acts as a diffraction grating, scattering the electrons in a predictable manner and resulting in a diffraction pattern. Clear? So electron diffraction is the phenomenon resulting from the interaction between electrons and crystalline materials, producing a pattern of rings or spots that characterize the sample. So the diffraction is the phenomenon resulting from the interaction between electrons and crystalline materials, solid materials, producing a pattern of rings or spots that characterize the sample. Okay. So the diffraction makes some spots on the sample. So let us see the next slide. The electron diffraction happens due to an elastic scattering, when the incident electrons do not lose their kinetic energy in their interactions with atoms. In some cases, however, even scattered electrons can be diffracted inelastically. And what is the use of this electron diffraction? As an analytic method, electron diffraction is used to identify a substance chemically or to locate the position of atoms in a substance. So for this purpose, this is mainly used, and we have seen several things in this presentation. We have seen photoelectric effect, we have seen Heisenberg uncertainty principle, and blackbody radiation, and electron diffraction. Thank you.